to Friday and the note well. Um, it's still got tiny print, but you're responsible to read it and adhere to it, both in conduct, in an IPR, and in anything you're saying will be in the record, both on the video and on the audio. So scan that QR code and find out what you're agreeing to. I hope this is a better Notewell short spiel. Tried to make it a little fun. So we'll keep working on the Notewell. Jeff, I think the only thing we need to do at this point is I need slides, or you need to put it to the end of the slide set so we agenda. There we go. Nope, we want to go all the way to the end. The last slide is the agenda. Yeah, is everyone hearing me fine? Rashid said he's having trouble. How is my mic? Good enough?
Audio in the room is great. If anybody can't hear on Mideko, could you please take a look at the room game?
Okay, Rashid said all good now. Okay, so this is the agenda for today. We've, as normal, got a full session, but today we're focused on those BGPLS, SR, and flow specs. So please, and extensions that Swadesh is talking to us about. So for SRv6 and MPLS. So please, if you have questions, speak up. This is supposed to be an interactive. Any agenda bashing? Having none, take it away, Jeff.
Okay, so before we get started, I wanted to spend just a moment to talk to all of you about the fact that this is the IETF, and we make progress working on our documents by working on other people's proposals that are our own as well. This is not a write-only working group. If you write a proposal, the best way to advance things, including everything here on the screen, is for you to provide cross-review with other proposals. And this review can be editorial, it can be technical, and as you see here, we have documents that are largely, thematically grouped into two things: either BGP link state things for segment routing, or some flow spec types of things. So, if you have expertise in link state and or segment routing, please look at each other's documents, provide commentary, and having received such review makes it a lot easier for us to push the document forward for last call. Having said that, we'll go ahead and get started with our first presentation.
Hello, this is Yao Liu from ZT on Saturday morning. So this draft is about supplement of BGPLS distribution for SR policies and state. And as we know that the SR policy information can be advertised via BGPLS. So various TLVs are defined to enable the header to report the state at different levels. For example, there are SR candidate path state TLV, SR segment list TLV, and SR segment sub TLV. However, a few segment list state related information is not included. The first one is whether the segment list is in the administrative shut state. In the network, the segment list may be shut by an administrator for a different purpose. So this state information may want be the controller may want to know the state information of the C list. And the second one is whether the segment list is a backup path. And the PC multipath working group document specified that and specified an optional option. It's about the protection among segment lists. So there might be segment lists in the candidate path acting as a backup path, and the backup path only carry rerouted traffic after the protected path fails. And another consideration is about the MPLS label stack entry in the seed list. So besides the SR MPLS seed, MPLS labels such as special purpose labels or entropy labels can be inserted into the seed list by the header node. And it is already supported that uh, uh, to report the normal MPLS LC informations via BGPOS. However, when carrying the MPLS LSE in the SR segment sub-TLV, it is specified that the TCS and TTL must be set to 0. But in some cases, the TCS or TTL information may also be required by the controller. For example, the MPLS MNA defines different LVC formats, and for some of them, as shown below, the LC format B, C, and D, the TC and TTL fields are repurposed to carry additional information, so they are carrying real valid data. So but reporting 32-bit LSEs without the TC and TT field set to 0 and inserted to the seed list via BGPMS is not yet supported. So the BGPLS extensions proposed in this document is first 2 new flags in SR segment list GLV. One is the S flag. It indicates a segment list using administrative short state was set. And the B flag indicates that the segment list is a pure backup path as specified in PC multipath was set. And the second extension is a new MPLS LSE sub-TLV in SR segment list TLV. It is used to carry one or more generic 32-bit MPLS LSEs regardless of the type. Yeah, that's all. Welcome feedback and comments. Thank you.
We do have a question from Ms. Zafar.
Zafar Ali Francisco. Can you go to slide number 2, please?
Okay.
Yeah. So I'd like to highlight in the last blue sentence, whether the segment list is a backup path. There was a discussion in PC working group about this. This particular way of doing things violates the SR architecture RSC, and there is some discussion that needs to happen. So I will highly encourage for the authors to be connected on that discussion, and because this draft will then depend on that outcome of that. The second comment is on the row above it in blue, whether the segment is in administrative shared state. I think we need to see in SR policy what is the right data model, because we have like policy shared, then CP being a shared label and segment list. So at least from the architectures or from a data model, it'd be good to have that clarification. Thank you.
Okay, thank you. So for your first question, thank you for one pointer. I'll stick to the discussion around the backup set list. And the second one, actually there's already an administrative short state for the SR policy candidate path in BGPS. So so this is an alignment, because in the real network, actually, sometimes we do shut a segment list. Yeah, thank you for suggestion. I'll consider about that.
Yeah, or you can also remove segment list. Anyway.
Okay, Sue.
Thank you.
Hi. Thank you for this presentation. Again, tying down reverse path is important for SR. We already have an adopted draft that has reverse path segment. So how does this work with the PCE multipath that you're referencing? Have you looked at that? do I need to send some comments to you on list?
So about the reverse pass segment, I
Mhm.
don't think this draft. So our draft will discuss about the reverse pass segment. So it is only some state or information report that is locally available on the head end. So as far as we can come out. So,
So you're
but
both,
I okay, please go.
oh, please go ahead.
Yes, so but I'll look at the working group draft about the reverse pass segment, so to see if there's anything need to be taken into consideration. But for now, it seems that it is not related.
Okay. Would Do you want me to ask the question on this in the list so that you send the response to the list, or do you want to just go ahead and talk about
Uh,
in regards to your draft? Why don't you post how it's not related to the reverse path segments and backup paths? If you start a list discussion, I'll be glad to work on that. If I don't see one in a couple days, I'll start some questions. Which way do you want to do it?
uh, so please send to the list so we can
Okay,
have a more detailed discussion.
I will send you questions on the list that are specific. But um, good. Thank you very much. I think you need to look at the whole reverse path segment and not just the PCE multipath. We need to look at multicast. We need to look at the reverse path segment and the regular path segment as it's approached from the head end. All of this is really good work. I just want to make sure we're not designing pieces that don't work into work. Thank you for your time.
Oh, yeah. Thank you very much.
Okay, thank you for the presentation. And a request to Zafar is that since you have opinions about how this does not quite align with existing work, please also carry that to the list. What we're seeing out of a number of these documents is since Spring doesn't necessarily talk about protocol encodings, we're getting the debate about how the things align happening in the protocol documents rather than with the subject matter experts know in Spring.
Okay, can you hear me?
We can hear you, Minshu.
Oh, okay. Thank you. Hi. I'm Wang Minxue Wang from China Mobile. So today I will introduce the BGP SR policy extensions for the path scheduling. So we have recently added a new use case. Networks require high resource utilization efficiency defined in RFC 8934, and which is parallel to the use case of TVR and some editorial updates. Oh, sorry. And maybe there is still new for some people, so I would like to introduce the motivation again. So there are three typical use cases. First is the networks with discontinuous links. And in these cases, the links between the network devices and the network controller may very weak or intermittent. So this is very typical in the resource preservation and dynamic reachability network, where the devices or links only work at specific time points. So in these cases, the real-time advertising may be untimely and causing packet losses. And the second scenario is networks with frequent topology change. So there are some cases that topology changes frequently. This is very typical when the number of networks entities is very large. For example, so a dynamic reachability network with hundreds or thousands or even more nodes. So in this kind of work, the paths change frequently, so that pose a great challenge to the network controller. And the second scenario is that networks requires high resource utilization efficiency, which referred from the RFC 8934. So traditionally, the usage and allocation of network resources can be supported by a network management system operation, such as path pre-establishment. So however, the established paths may reserve the resources for a long time, but the flow may just last for a short time. So this leads a waste of the network resources. So the pre-installed forwarding paths with time constraints can solve the problems. And so we extended the BGP as our policy with a time informations, schedule time informations, including the schedule ID, start time, end time, recurrency count, and frequency, etc. So how to use the time information? First, we can advertise the SR policy with the schedule time information, and the controller or PCE can compute the SR policies and associated schedule time information sub-TLV, and this policy and sub-TLVs can originated by a BGP speaker. And each schedule is identified by a schedule ID, and the controller or PCE ensures the schedule ID unique within a specific SR policy. And the second step is the reception of the SR policy with the schedule time information. First, we do the validation to check the uniqueness of the schedule ID and the rationality of the time parameters. So when SR policy encapsulates schedule time information sub-TLVs at both Kennedy path level and segment list level, then the sub-TLVs at the segment list level should be used. Then we can enable or disable Kennedy paths and segment lists. The head ends faces the SR policy and saves the schedule time information locally, and the head end dynamically enable or disables different candidate paths or segment lists based on the schedule time information. So there is a question. So is this a format of the time information aligned with that in the TVR or PCEP? So answer, the format of the time information in TVR and the PCEP are a little bit different. So we'll also request the deputy to give some suggestions on which format to choose. So like the TVR, a complicated one or just a simple one. So the next step, we are moving forward to the WG adoption, and also welcome for comments and suggestions. So that's all. And another slide is for some questions.
Yes, you have several questions. First one at the queue is Zafar.
As a file Cisco system. So I passed this comment to IETF back as well, that and I'm not sure if the requirement came from TVR working group or not. So that was one. Second thing that I passed the same comment there as well is this could be done from a controller, and giving these kind of complex schedule and signaling for that, I think it just brings a lot of complexity. And so that's my opinion. Thank you.
Thank you. AC?
AC Linda Marcus. Yeah, I have a similar comment, and I'm one of the authors on the TBR scheduling draft. So how would you position this versus that schedule? That actually controls the link, whereas this advertises what it's gotten from that Yang model and then advertises it to PC. Is this what this is for?
So I got three questions. The first one is about the relationship with the TVR, and yes, we first have a use case in TVR, and then we have expanded the extension for BGP, so we came to IDR group, and maybe in IETF.
As a follow-up,
One,
AC, would you please send to the list what you think the desired outcome would be if you think TVR needs to be more directly involved here? Thank you. Li Zhang?
Yes, I think I can just respond to the question from Zephyr, and I think there is no requirements for TVR, and this draft is not only for TVR, it also includes the use cases described in RC 89 and 34. And I think this is a more general draft for scaling paths. And for the second question, why not run the schedule in controller? I think we have explained this reason in the motivation part, because in some scenarios the connection between the head end and the controller is not very stable and maybe intermittent. So I think sometimes in some scenarios it is needed to send the schedules to the device for a period of time instead of advertise paths to the device whenever the change is occurred. So that's my response.
And before we hand off to Sue, a comment from chat that I asked originally towards Dhruv. Dhruv had provided prior feedback that we should use the formatting that PCE suggests in RFC 8934. It's sounding like the format may be correct, but maybe it'd be better to refer to this to that RFC for the definitions rather than redefine things. And I think this goes towards a more general comment about this draft. We've seen this draft presented many times. I don't think there's a strong disagreement about, so even small details about the encodings, but the use cases seem to be the conflicting point here. The same thing can be done in many different ways, and BHBLS is just another way to do this sort of thing. So one of the things I suspect we'll want to discuss as a working group is, it's not necessarily our job for being the stewards of this segment routing code points for BHBLS to limit the use cases, but certainly we want to encourage the various groups trying to accomplish the same things to have consistent mechanisms. So I'd recommend that we have our discussions along those 2 points, the encoding, which I think sounds like it may be fairly well established now, and the use cases is a separate one where AC has promised to send at least one of the cases. Sue?
Yeah, you and I are aligned in our thinking. I would add, please, if you're in VGPLS, make sure you also talk to Spring. We need to see a clear case of the use cases. I think I pointed you at Spring and PCE and TVR and and PCE for encoding. So if we can get the use cases, we can make progress on this, but we don't really have a strong clarity on the use cases. Maybe you could do that, start, you don't have to have a draft. You can start with just some text on the list so we can start to work on these use cases. Hopefully that's help. Uh, we can, Kare makes a good point that I'll add in. Um, the working group will also, and these groups of working groups should say, do we need multiple ways to enforce the same functionality? So that's part of the discussion. Use, and then an overall look across all the working groups. Please keep going on this and focus on those areas so we can go on to the next step. Thank you.
Thank you for your presentation, Joe.
Hi everyone, this is Taiwan Lin from New H3C. This draft is about the BP extension of SR policy for composite CP. Thanks to our co-author Wing Jiang from China Mobile and Lam from JT. First, we see the background as described in FC 19.2.15.6, a composite CP act a container for grouping SR policies. A regular SR policy CP output traffic to a set of segment lists, while an SR policy composite CP output traffic recursively to a set of SR policies on the same head end. As shown in the right figure, the SR policy 100, which has a composite CP reference policy 1 and policy 2 by colors in the composite CP. Also, as described in section 3 of PCE draft, the PCE already support dispute composite CP. However, there is no similar mechanism in RFC 19.8.13. So this draft define the extension of BP to dispute SR policy carry composite CP information. SR policy with composite CP information is described as the below. In the CP of an SR policy, the constituent SR policy attribute subtheory is defined. This theory includes color and weight. The color is used to reference the sub SR policy. The weight is used for loading balance. The constituent SR policy subtheory has the following format: 4-byte color that indicate the color of the constituent SR policy. 4-byte weight that indicate the weight associated the composite CP for the weight load balance. Also, an operational per flow forwarding class subtheory is defined. 3-bit forwarding class value is given by Q classifier to traffic entering the given CP. Here is a specific use case. We can use the BP to dispute SR policy 100, SR policy A, SR policy B. And also SR policy, when distributing SR policy 100, policy A, B, C are referenced by the color in the composite path. And the folding class subtheory is used to map traffic with different DSCP to the suitable path. This draft first presented at IETF 120, and now it is stable now. We think it should be an enhancement to RFC 19813. So the author would like to request WG adoption of this draft. That's all. Thanks.
There's nobody at the microphones, so you have the cue.
Thank you. Thank you for the presentation. Would you go back to the slide that shows the waterfall diagram with where this fits in the segment? Not the use case. I want to make sure I understand. Start it. There you are. I call that a waterfall diagram. It's a worse water reverse. There's the tunnel and caps at top. So here's the question. Okay. The tunnel and caps has the ability to put color in it in one of the TLVs. Okay. How does this interact with this constituent RC policy color and weight versus the other? And I don't see in your use case what the interaction is and what you do here. So maybe you could go back and explain to me those points just a little bit so I can make comments that are helpful and not hindering. Go back to your motivation now that you know the context of what I want. Go back 2 slides. Okay, here's your motivation. So you're talking about 9256, and it has a candidate path that asks us container for grouping SR policy. That container is part of the TLV under tunnel and caps. Okay. And in that tunnel and caps attribute, there is a color. How are you relating the color in the tunnel and caps attribute with the rest? It may not be similar or not. I just am not seeing you talk about any of that. And let me give you the 9012. Have you looked at 9012? I mean, sometimes that's not normal for people doing SR routing because there's the tunnel color extended community that interacts with the tunnel color TLV. But you're starting to talk about color again, and I'm just asking for precedence, etc., relating to the color that's in the general tunnel in caps piece. Does this not make sense, or shall I send it to the list?
Yeah. And the policy has the same endpoint, so they can use the color to find the sub policy and form the relationship between parent policy and the sub policy.
Okay.
We can add some text in the draft.
Okay, I will send this. If my question is unclear, I will not keep time. G, what I'm asking about is what's the precedence with the tunnel and caps color, the community color, and this color? There should be a clear definition of precedence between all of it. It's not this specific mechanism, it's how this specific color mechanism relates to the place that SR that the SR policy uses to plug into the tunnel and caps, which is the attribute you're carrying this in. I will send a specific question unless there's someone else that wants to ask more details of my question. Okay, second question for the list. You're proposing an interesting color and weight, but it has to relate to the other things this particular thing fits within. You either have to say it doesn't relate or it does relate, and I'll send that question. Thank you.
Thank you.
Thank you, Sue. And Changwang, please look at the list, the chat for the IDR session. You'll see a clarifying question from me about this, and Sue will follow up on it on the list as well.
Yeah, okay, thank you.
I will start with Jeff's general question and then make it very specific for the mechanism you've proposed.
Okay, your next presentation, please.
Okay, this is another draft about the BPL's extension for Asapolis composite CP. Also thanks to our co-author Wei Qiang from China Mobile and Java and Aladdin from Cisco and Lam from ZTE. So the background is same to the BP dispute composite CP. Up say 19.8.15.7 described advertised or Asapolis using BPLS, but it doesn't define the method for advertising composite CP. So this document specified the extension of BPLS to carry the composite CP information in the advertisement of an Asapolis. The current BPL's advertisement of Asapolis is described in the figure. An Asapolis is advertised through the Asapolis CP NOI, which announced an CP pass. The composite CP TLV can be included in CP NOI link attribute. The composite CP TLV has the following format. The color and the weight is the same for the previous draft. The color is 4 bytes indicate the color of the sub Asapolis. The weight indicate the weight shows the weight the composite CP. Also the forwarding class define 3-bit for forwarding class to given by the queues classified to the traffic enter the given CP. This draft it would be an enhancement to UPSA 19.8.15.7. So it is stable now, and we would like to request the WG adoption for this draft. Thanks.
Okay, there's nobody in the room. So did you have a follow-up?
The author should go back to slide 2. Please. Okay. We're depending on 2 things that I just made comments on, so those comments will reference this. You should look at those because those pieces of information need to be solved. The PCE multipath and the reverse path, the composite path, and any color you put into it. So I'm not going to repeat those for this. I'm going to assume that you'll read those other threads. Now go to the next one. Next slide. Okay. So those are things for the SR policy. You're now asking this in BGPLS to pull this information. I have to ask the same questions on color and weight, that we have a consistent idea of where we're pulling color and weight from, if there's inheritance, if this is really going to the head end and the head end is pulling color and weight. I would wonder, if I was an operator, is where's that being set? That may not be just because I would be a cautious operator, having had problems in my past with where things get set. So part of this is a bit of a good idea, but we need to carefully distinguish, if you're pulling this from BGPLS, is it being pulled? If it's being pulled off the candidate path, is the candidate path picking up its color through a precedence of color? Are you reporting things like, because my understanding from your text is you're pulling it from the head end. Do I understand that right for the BGPLS? You're pulling on an active candidate path, or you're pulling on a potential candidate path?
It is below the link attribute.
Yes, I understand it's when you set the link up at the, okay, you're choosing as the link. Well, maybe I don't understand. What this is all part of the color thing that the IDR chairs have found out. There's lots of ways to do color, and you're now pulling out information that we're wondering how it gets set. That's the big picture. Now, this is on a particular link, but a link, if I understand your text, and I may not, is you're giving it a composite candidate path, which is a set of things that could be set in various ways. The question is, how do you identify where it gets set? It's set on a link. If you're setting it from an SR policy, are you keeping the details of where the color came from? Is it from the tunnel TLV? Is it from a color TLV in the at the TLV level in the attribute, or is it at a sub TLV level? And I don't find the specificity in your slides, and I didn't think I saw it in the draft. Again, is my question, it's trying to be very specific about the problem. Am I making sense in this brief verbal description, or should I send a message to the list?
Okay, I'll see in the mail list.
Okay, that's fine. I will queue this up as another one of the message lists. I'm now getting a little behind, but I'm glad to do it. Okay. I will just ask the color transport. Okay. It's the color question again. Where do you get it?
Yeah.
So thank you for your. This is good work.
Yes.
I just need more details.
Yeah, thank you.
Thank you.
I think the color in the composite path theory is not the color theory. The color defined in the candidate path theory. So I can see the RFC 1912 and then response to you in the mail list.
Why don't you do that? That'll start the conversation. This is good work and interesting work, but needs to be more detailed. So why don't you send that to the West, okay? Thank you.
Yeah, thank you.
Hi, can you hear me?
You're loud and clear, Yusha.
Okay. Hello, everyone. I'm Yujia from Zhongguancun Lab, and the topic of my presentation is about the package content filter for BGP flow spec. Next, please.
You should have control of the slides.
Oh, I can control it. Oh, okay. Yeah. Here is the draft status, and we first proposed the filter in IETF 119, and we do some conduct software router function development and testbed validation, and discuss with some vendors and operators to optimize the filter definition. And today I will introduce the latest progress of this work. Let's start in the problem statement. In September this year, Cloudflare defends against 22 Dbps DDoS attacks, less than a month after the last record of 11 Tbps. This indicates that the intensity of DDoS attacks is growing far beyond expectations. Defending against such massive attacks relies heavy on scrubbing center alone. Moreover, in operator networks, we captured some real DDoS traffic, including ACK flood and SSDP reflection attacks, as shown in the slides. These attacks use carpet bombing or random IP or port patterns, which make them difficult to identify, often causing direct service disruptions. Fortunately, we found that such attacks may share fixed payload characteristics, which can serve as a solid basis for defense. By leveraging network devices together with full-stack capabilities, we can mitigate these attacks before the traffic coverages and grows into a large-scale event. To achieve this, we propose a new flow spec filter designed special to match the fixed payload characteristics. We call it the package content filter or just the payload filter. In previous meeting, we introduced its field definitions and ordering rules in detail. It's designed to comply with FlowSpec v2 and is proposed as a kind of more IP filter. Here is a typical use case. With FlowSpec and payload filter, we can either limit the rate of traffic on the router or redirect it to the scribing center for more detailed mitigation. To evaluate the effectiveness of the payload filter, we conducted experiments on the open source router platform. We built a testbed consisting of a controller, multiple routers, and hosts, and test the filter's defensive capability against various types of attacks, including UDP flood, SMP flood, ACK flood, and some simple reflection and amplification attacks, as well as application layer attacks such as HTTP flood. The results show that the payload filter can effectively block these attacks and reduce the load unscribing devices. If everyone interested in the experiment, the detailed test setup and the source code are available on GitHub. We are now collaborating with device vendor to implement payload filter on commercial devices. This will enable further testing of payload matching against the hardware performance pressure and confirm its effectiveness in operator networks. During Tuesday's meeting, the chair mentioned that FlowSpec V2 work will be advanced in the near future. We hope to request an adoption call in the following steps. I hope to get more feedback. Thank you.
So prior to you, we have a question from Maria.
Hello, sorry, I thought that she is before me, but she just didn't leave her hand or something.
It is fine not to have me. I'm
Okay.
I'm an author. I forgot to lower my hand. Thank you.
Oh, sorry. Yeah, thank you for this draft. I think it's a good way to go, yet I am having some concerns about how to say it, maintainability to the future. I'm looking at the p-type fields, at the o-type fields, and such that I am thinking whether this deserves an INA table, because this is not going to end here. It's gonna end with some tunneling headers and probably MPLS and whatever. And I'm very scared that this is going to be a big mess in this part. And the second part is I'm very much lacking any security considerations, considering that this might go through an AS boundary, and then I am scared that I miswrite a packet content filter and I kill my BGP. And then the control plane goes down, it's removed, the control plane goes up, and I get an oscillation. And that's something I'd like to at least have a note about. Thank you for considering this.
Thank you for the question, and I think it's a good insight about for the some protocols such as Terno or MPLS. Maybe we don't need to use this kind of payload filter. And this can be used to defend some DDoS attacks or some or some information in the TCP or UDP payload. And we also will consider about the question. And thank you.
Thank you. A follow-up question from myself to prior comment from Maria. So what you're documenting is to some extent a generic operational consideration for BGP FlowSpec. FlowSpec does cause unfortunate outages and is notorious for doing so. But that said, it has also been a very powerful tool to help operators deal with things that otherwise are very challenging to deploy. What I would like to encourage you to do is, since we are picking up this work again as part of FlowSpec version 2, if you have considerations, operational considerations, security considerations that you think are important, please consider contributing towards those in the new document. And my second comment is addressing a point that Robert has raised in the chat that is worth including into this document as well. Payload matching as part of a firewall operation is certainly something that works very well on smaller security appliances. However, FlowSpec is used not only on such security appliances, but also edge internet routers as well. And a relevant point from Robert is that these things do have different scaling considerations. So I would encourage you as part of your document, to discuss the scaling considerations for this feature. Thank you. I see there is
Okay.
a follow-up from
Thank you.
Jonathan as well.
Jonathan Mitroptic. So I suggest in the same direction actually that was proposed by this gentleman, I forgot your name, sorry, that you define or potentially suggest ways to implement this, because in some vendors, hardware is just impossible. You mentioned it there, but you have to statically define the actions that FlowSpec can do, because the ASICs cannot actually do these kind of filters. Potentially provide ways or suggest ways to implement those extensions in the hardware, because otherwise it won't happen, and it will just be flooding the routing engines instead of actually filtering traffic. That was my point.
Okay, thank you for the comments, and we will consider about that, and maybe can discuss through the mailing list later. Okay, this is a second presentation. It's about the BGP FlowSpec extension for feedback binding. It's first proposed, and this work focused on enabling closed loop operation for BGP FlowSpec, so that the network controllers can truly know whether FlowSpec rules are not only delivered but also effective in the control plane and data plane. And as we know, BGP FlowSpec is very popular for distributed traffic steering, especially for DDoS mitigation or the traffic optimization in carrier networks. From the control plane, everything looks great. Controller can distribute FlowSpec updates through BGP, and peers quickly acknowledge those updates. However, that doesn't mean the rule is actually working in the data plane. Sometimes the router accepts the FlowSpec rule, but traffic still passes unchanged, maybe because of a local ACL or a hardware limitation, or simply because the route was never activated. So today, FlowSpec works only in one direction. The controller can send rules, but it has no visibility back to confirm whether those rules were really installed or effective. This one-way control nature is what motivates our work. We want FlowSpec to become a closed-loop system capable of both distribution and verification. So here is the problem statement. In practice, there's often a clear gap between what the controller think is happening and what's actually happening on the routers. In other words, rule delivered that doesn't always mean rule effective. We've seen several typical failure scenarios, such as policy or ACL conflicts, FIB installation failure, inactive roles, or inconsistent vendor behavior. There is no standard feedback path. the controller cannot tell which routers actually enforced the rule and which didn't. So operators are effectively flying blind. They need clear real-time visibility into which node has truly enforced each rule, so they can perform dynamic optimization and avoid defense blind spots during DDoS attacks. And that's why we propose a feedback framework. Now let's take a look at how the feedback framework works. Each flowback route now carries a feedback action, basically a unique ID that lets the controller trace how that rule behaves in the network. When a router receives the route, it installs it into the RIB and FIB as usual, and reports back to the controller on whether the installation succeeds. To enable this, the router can establish a telemetry session with the controller. Then the router sends event reports and hit statistics from the data plane, such as how many packets matched, whether the rule is still active or if it's gone idle. On the controller side, all these reports are correlated using the same feedback ID, giving a complete end-to-end view of rule enforcement across the network. With this closed feedback loop, operators can detect inconsistent reissue rules or trigger automatic optimizations. In short, what used to be one-way control has now become bi-direction feedback. Flowback not only tells router what to do, it can also see whether they actually do. Here is a specific use case for large-scale DDoS attacks. After a router receives a flowback route, it can move through several status, such as receive, install, active, or effective, and remove. Each status means something has changed with that role, and every time it changes, the router can report the event to the controller, enabling operators to optimize the roles in real time. To better illustrate the situation, we propose a potential feedback action encoding. To achieve a closing loop, a lot of fields are required. We need to consider whether the action encoding is performed through the large community or the community container. This depends on the implementation flexibility and future extensions. In summary, we propose a problem statement for feedback action and introduce a feedback framework to enable closed-loop flowback operation. We also provide a preliminary definition of action. In the future, we plan to confirm requirements and the community interests, refine the definition and encoding based on discussion, and extend the framework to include BMP or other telemetry-based feedback reporting in future revision. This may be related to other working group. At IDR working group, we aim to introduce feedback action as part of flowback V2 to enhance automated defense capabilities in carrier networks. That's all. Thank you.
Jonathan, you had a question? Okay. Move Jonathan to the queue. So Yuja, thank you for the presentation. As somebody who is working on FlowSpec version 2, I think you are doing a good idea here, and discussions about how to do a feedback loop for installation of rules is something that we have talked about as part of FlowSpec in general and FlowSpec version 2 in particular. And I think there's going to be a lot of room for us to discuss what this mechanism looks like. So we look forward to further presentations on this. One piece of feedback is that you probably can't use large BGP communities for that. There's no standardized code points to do such things. And the current conversation is the community container is where we're looking to do such things.
Thank you, Jeff.
Thank you, Yusha.
Hey everyone, I'm Swadesh Agarwal from Cisco Systems, and I will present BGP extensions for SRv6 and MPLS transport interworking to signal the SRv6 SID in the BGP LU SAFI. So, as you guys might already be aware, that there is a Spring Working Group document which describes the SRv6 and MPLS interworking architecture in the multi-domain network, where each domain run SRv6 and MPLS data plane independently. And as a part of that work, we have defined new SRv6 behaviors such as DTM 46, DTM, and DPM for the purpose of transport interworking. There's also a draft in the SRv6 ops, which gives the guidance on the operational for the same solution, operational use guidance. So this draft, the purpose is to how to signal the SRv6 SID of the above behaviors with the BGP LU routes for the transport interworking. This draft replaces the existing best draft, which was introduced a couple of years back. And the reason this is being introduced now in IDR is because this is for core BGP transport and not for BGP services. So as a part of this work, we have defined a new TLV, which is called SRv6 transport TLV of the BGP prefixed attribute defined in RFC 8669 to announce the SRv6 SID for the behavior, for the interworking behaviors with BGP LU SAFI. SRv6 transport TLV is encoded exactly like SRv6 services TLV in the prefixed attribute, which is specified in RFC 9252, and reuse the BGP SID info sub TLV as well as SID structure sub TLVs. And of course, the TLV is used for for these behaviors which are required for interworking. And these extensions, because this is using BGP-LU SAFI, leads to signaling of both label and SRv6 SID with the BGP-LU routes. And so as a part of the Spring Working Group draft, there are two ways to transport the BGP-LU packets or the LSP across the SRv6 domain. So one of them is using the DTM 46 or DTM behavior, which encapsulates the MPLS packet for using the MPLS packet into the IPv6 header to transport the BGP-LU LSP across the SRv6 domain. And to accomplish it, the proposal is we use the existing BGP-LU procedures for each of the PE addresses, which is advertised in the BGP-LU updates. And it follows the regular procedures that border node allocates the label for each BGP-LU prefix when setting the next hop to self and advertise to its upstream routers as specified in RFC 8277. This draft additionally recommends that you allocate a SR6 SID of end.dtm46 or end.dtm behavior and encode that in the SR6 transport TLV exactly like SR6 SID, but without transposition with each of those BGPLU routes. The same SR6 SID can be signaled with the multiple BGPLU routes by the such border routers, and the reason being all the P's sitting behind that border router can share this SR6 SID to transport those LSP through the SR6 domain. And this, the behavior that DTM 46 or DTM signals the AND semantics means you have to do existing BGPLU swap operation, and then you have to encapsulate the packet into IP6 header with the DA as a SR6 SID of the being signaled in the TLV. Such transport TLVs can, transport traditional services, any of them, which could be global table, VPN, or eVPN through the SR6 domain. So this one is more of a, shows how it works. And the example here is the MPLS layer 3 services. Between E10 and E1, we are running the services through the service ARAs, and we advertise the service with the next hop as the E10, which is a P, egress P. And now we have to advertise the egress P reachability to the ingress P, which is E1, through this transport network. And as you can see, in middle, we are showing SR6 domain, and on the edge, we are showing MPLS domain. Now, existing, BGPLU LSP is advertised from the by E10, and it's being learned by ABR7, which is performing the next hop self for that P address. And ABR7 upstream is an SR6 domain. So what it does is it's additionally, advertise the SR6 SID of the DTM46 or DTM behavior, and it's advertised to the ABR4. And ABR4 then advertise it as a regular to the BGP LULSP to the E1, performing whatever RFC 8277 recommends. So as you can see, in this case, ABR7, when advertising, it can send the same SR6 SID for multiple PE sitting in the, on the right domain, not just one. So therefore, this SID can be shared. So another method that the Spring Draft recommends is we can do is a per prefix SRv6 SID allocation, which creates a translation between SRv6 SID and the label, and that is it's like a swapping entry we are creating on those border routers. So what it requires is, like in BGP LU traditional operations, border router allocates not just label, but the SR6 SID bounded to the prefix or a PE address, which is carried in the NLRI. And the SID is of the DPM behavior. And of course, this is unique for BGP LU prefix now. And we encode, of course, label is encoded as per the existing BG8277. But as a part of this work, we encode this SR6 SID into this new SR6 transport TLV, but exactly like SR6 services SID TLV encoding. And the receiving node performs h.ncaps with the destination being the SR6 SID being advertised for the traffic destined to the address in the NLRI. This encoding allows the signaling of both the label and the SR6 SID, assisting in migration by allowing the receiving ABR to select the relevant encapsulation. This one shows how it is working in a more simple manner. It's exactly same. We have a layer 3 VPN services. It's advertised exactly same way. But on the ABR7 here, when you learn the BGP-LU LSP for PE10, what you do is, in this case, ABR7 is allocating SR6 SID of the DPM behavior for each of those PE addresses. So it will carry a different SI SID for each of the PE address. And on 7, you install the DPM behavior would be installed in the forwarding, its pseudocode as per the Spring draft. And on ABR4, when you receive such an update, for each incoming BGPLU label, you swap to or you remove the incoming label, decapsulate, and then put the IPv6 header with the SIFC SID learned from the ABR7. So, as authors would like to receive the feedback on this work, and also since we have a strong operator interest because of the deployment of the SRv6 in the brownfield networks, as well as we have implementations underway for this work, we will request for the adoption of it. Thank you.
Thank you, Swadesh. Kayur has a question.
Hey, Swadesh.
Hey, Kayur.
Great document. Kayur Patel Arcus. One quick question I have is I was looking at the draft. It doesn't talk about error handling procedures and the fact that the receiving router doesn't support this TLV. What would you do? I think the draft would benefit from some text that says, here are the kind of things you would do if you don't understand this TLV.
Sure. I will. I had to update the error handling. Yes, Kayur, I'll update with those procedures.
Thank you.
Yeah.
Are there further questions? It looks like not. Thank you, Swadesh, for the presentation. This concludes our presentation for IDR and IDR 124. We are intending next to meet for IDR in 125 in Shenzhen. So we'll see you there. And as you're heading out the door, we would like to take this moment to thank Jidong for actually doing the secretary work that enabled us to run this session so smoothly.